Hello everyone and welcome back to the channel. This is Praveen here. I hope you guys are extremely doing good. So after the completion of 3 mega projects for you all, in the week 1, we have completed AKS plus Terraform, AKS plus Argo CD, and yesterday, right, which was Saturday around 6 p.m., we have covered EFK plus AKS, where we have done the Elasticsearch Kibana Fluentd deployment via the pods, and we have seen how the cluster monitoring was happening and the pods monitoring was happening. And today we will be specifically looking at the Kubernetes real-time troubleshooting, how the pods gets troubleshooted, how the cluster gets troubleshooted, where to check the logs if some issues are happening in the cluster, where to check the logs if some issues are happening on the nodes. What are the main criteria you as a DevOps and SRE engineer should follow to make sure that your cluster is up and running and you give 24/7 uptime to your applications, right? So let's get started. I'll be sharing my screen and I have some details for you which will be helping you to analyze the data. So first of all, whenever we discuss about the troubleshooting, guys, and I would request you all like the video and subscribe to the channel if you are new to the channel. So this is basically free boot camps which I run on the channel, and this is for you all. So today we are going to talk about the Kubernetes troubleshooting scenarios. And very first important thing whenever we discuss about the troubleshooting, right? Whenever we discuss about the troubleshooting, we have to see the 3 main pillars, not only on the troubleshooting, but whenever a DevOps and SRE engineer works on any kind of troubleshooting, he should think in a very different perspective. The 3 pillars, that is why I have kept the first slide for you to understand that these 3 pillars are very much important. Now, what are these 3 pillars? First of all, understanding the problem, right? If you are a DevOps and SRE engineer, you will be going into the P1 calls, P0 calls, on call. So you will be doing support, right? And you should be making sure that, first of all, you need to understand the problem whenever you are pitching onto the on call or whenever there is a production issue. First of all, you need to understand the problem, right? That is what the main agenda is. You as a DevOps engineer should understand the problem. Then you should be thinking of, like, once this is done, you understood that there is an issue in the cluster, there is an issue in the node, there is an issue in the pod. So you as a person should be able to understand how do you manage and remediate the problem, right? So you need to understand the problem and find a solution for it, right? You need to find a solution for it. So the next one comes like finding a problem, then finding a solution, then preventing the problem from reoccurring. Because let's understand that you have done these two, but again, after 2 days, the issue occurs again. Then what will happen, right? What will happen? Your manager will say like, hey, Praveen, you have fixed the issue, but still the issue is coming. Can you check? And again, after 2 days, if the same issue is coming, then it is an escalation problem because you are doing this continuous issues on the production. So you should be making sure that you understand the problem, find a solution, and doesn't allow it to reoccur again. So all the things, right, of identifying, diagnosing, resolving issues in the Kubernetes cluster, nodes, pods, and containers, this video is for you. So let's get into the next slide. I will clear the slide here and let's go into the next slide. So in the next slide, I have started with the pods troubleshooting, guys. So first of all, you need to understand whenever a pod is given, right? So you all have done the Kubernetes projects. I hope you have done my previous projects. If you have not done, join the Telegram group in the link below and you will be able to understand how the things are working for you with the project document. Suppose we have created the AKS cluster, Azure Kubernetes in Azure, and we have deployed some pods, let's say 3-4 pods in the Kubernetes cluster. Now, we are seeing that there is an issue in the pod. This pod is having the issue. Now, what kind of issue? How do you solve it? Now, I'll be making it red and this pod is having the issue. Let's understand it. The first and the foremost command you need to run to find out your pod issue or find out the details of the pod. First of all, we need to identify the details of the pod, right? Without the details, how we can actually go the debugging. So first command you need to apply on this Kubernetes terminal is kubectl describe pod name, right? So you need to check with this and you will get all the details of your pod. So let's take what are the details you will get here. The pod details, the network details, the size of the pod, the CPU, the memory, everything, the container details, everything you will get in this kubectl describe pod name, right? And you need to understand this pod name is a random digit number. You will be seeing like MySQL hyphen 1 2 3 4 5 6, some hexadecimal values will be there, and maybe nginx hyphen pqyz 1 2 3, something like this hexadecimal values will be there. So that is how the pods are getting deployed, and basically we will use a kind concept of deployment as I have told you in the yesterday's class, where it will generate a random name, right? Now let's imagine that once you have seen that kubectl describe pod, you have given the pod name and you are seeing something called status of the pod. There will be always a status of the pod which will say like there are few status of the pod, like exit status, right? Exit status, or a pod running status, container running status, right? And you will also see like pause status. So these are all some Kubernetes pod status. And according to that, you see pod staying in pending. Now, whenever you see something like the status of the pod, when you say 𝐀𝐝 it will describe pod name, you should be understand that either of these are some issues. Let's see what are the issues. Insufficient resources in the cluster. So you need to understand that your cluster is like a laptop, guys. Very, very important. Your cluster is like a laptop, which is helping you to assign some memory, assign some CPU from itself to its pods. Okay. So your laptop is, let's say your laptop is having 4 GB of RAM. From this 4 GB of RAM, you are assigning your pods 1 GB of RAM and memory. So that is kind of a parent-child relationship. You need to understand your resource. Your cluster itself is having insufficient memory. Then you need to, if you are a Kubernetes admin, you will be scaling up your cluster. You will be assigning some memories and CPUs to the cluster, right? The cluster may have insufficient CPU and memory, and always consider your laptop as your use case. Your laptop, when it becomes overloaded, when it doesn't have the CPU, when it doesn't have the memory, you need to understand that at that point of time, your laptop is very, very, very weak, and your laptop will not be efficiently running. So this means that you will need to delete some pods, or add resources to your nodes, or add more nodes. So in this case, let's understand this. This is your parent laptop. And what are you doing? You need to add some clusters, Kubernetes nodes, right? You need to add some nodes. You need to increase the size of the cluster, or delete the existing pod. Any of these things you can do. And also, when it comes to the resource requirements, the pod may be difficult to schedule due to specific resource requirement. See if you can release some of the requirements to make the pod scheduling on additional nodes. Very, very much important. So these are some things which you can do. And always make sure you go to the Kubernetes dashboard and see the data, right? Live data. It will show you. We have done all the projects on our channels. Just go to the playlist. You will find all the free bootcamp 1, 2, 3, 4, 5, 6 playlist. In that, we have covered all these things, how you go debug the pod and everything. But this is on the next level of debugging, which I'm going to tell. Now understand that the pod status, when you have it, 𝐀𝐝 describe pod name, the status of the pod is in waiting state. So what does this mean? You understood pending. What you have to do, it is basically CPU and memory. When it comes with waiting, you need to check that whether your image name, right? Basically, I have also told you the 3-rule theory. The app will be there in the form of jar, and then it comes your container will be there on top of it, and then your pod is formed on top of the container. So jar, your app, then your container, and then your pod. Okay, then your pod. So basically, pod states waiting. In the case of waiting, you need to check the image name, whether it is correct or not. Image available, ensure that image is really available. If the image is not available, also the pod will go into waiting state, because pod will not find the inside layer. The container will not be found, right? A test manually, run the docker pull command. So basically, you need to test if the image is perfectly fine or not. So whenever a waiting state happens, right, your brain should be tickling over the image value and image availability. Whenever there's a pending state, your brain should be tickling on your resources state. So I hope this is making you understand like how important these kind of definitions or the troubleshooting will help you. Now let's go into the next set of things where you can understand how to diagnose a pod. Very, very much important. Let's understand that you first find out the issue. That's what in our three use case, which I've told you, find the cause of the issue, then troubleshoot it, then fix it, right? So diagnosing other pod issues, let's understand. You need to check the pod logs, right? You need to check the pod logs, or you need to do the debugging with the container, right? So I have told you, right? So 3 layers are, this is an app layer, this is a container layer, and this is your pod layer. So there are 3 layers which are very, very much important. So here you need to understand examining pod logs, very much important. You need to check the pod logs. At the same time, you need to check inside the container what is happening. So Praveen, how do you go inside this? How do you go over the layer number 1 and layer number 2? So that is where we have some commands, right? kubectl logs pod name and the container name. So basically, examining the pod logs will help you, like kubectl. The command is kubectl logs pod name, as I have told you, pod 1 hyphen 1 2 3 4 5, and the container name. Some container name with the container ID will be there. You can give some container name as nginx, and you can check the logs. At the same time, suppose you want to go inside the container and check the data. That is where debugging with the container exec. This is what execute command means. kubectl exec pod name hyphen c container name and bin bash. So basically what will happen, suppose you want to go inside the container, kubectl exec pod name, right, hyphen c the container name of the container, and bin slash bash is the type of login which you will do inside the container. So basically here some kind of logins are bin slash sh, bin slash KSH cron shell, bin slash bash, shebang, KSHL cron shell. All those things are useful for your pod issues and understanding in the container how these are happening. Very, very much important. Now let's go ahead, like you diagnose the issue. Now there are some issues, other issues. Now you understood with the 5-4 issues which are happening with the pod. Now let's understand, like, on the cluster level, what are the important issues that you are going to face it. Now, on the cluster level, let's see, like on the laptop itself, there is an error, right? On the laptop, you are actually having a laptop and you are creating 3 more laptops, and in that you are deploying some applications. So everything is dependent on your parent laptop, right? This is your parent and these are your child, C1, C2, C3, or node 1, node 2, node 3, right? And you need to understand, suppose this node type is your basically is your master, right? Kubernetes is having always the 4-rule theory, which I explain, right, to everyone. Master node and the worker node. There will be always a master node and the worker nodes, right? So these are like master node and these are like worker nodes. This forms as a cluster. So let's understand there is an issue in the master node in the component of API server. So basically in the Kubernetes, there are 4 components in the master server. The 4 components in the master server are API server, okay, and then the etcd, okay, scheduler, and one more thing, API server, etcd, scheduler, and control manager. Okay, these 4 components are there. And suppose in the master node there is an issue with the API server, which log you have to check? You have to do a cat, okay, var log kube hyphen API server dot log. So under, you need to check it. So everything is Linux, right? In this world, everything is Linux, right? And in this Linux world, you need to understand, like, where is the important folder where you can keep your logs, all the system logs, all the important logs are here. Where log kube hyphen API server dot log, you need to check if your API server is not working. Suppose your scheduler on the master node, as I've told you, the 3rd component is not working. You need to do cat, or you can use tail hyphen f also, tail hyphen f, the file name. So file name is what? Where log kube hyphen scheduler dot log. Suppose in the master node, your control manager is having issue. You can check here cat, right? And you will get all the logs related to that. Suppose in the worker node. So in the worker node, again, there are 4 components. What are the 4 components in worker node? You will have your kubelet, kube proxy, okay, kube proxy, container, container D, okay, and then your pod. Okay, suppose you are having issue with the kubelet and kube proxy in the worker node side, where you will check where log kubelet dot log, where slash log kube hyphen proxy dot log. So these are some debugging mechanism where you as a Kubernetes admin should take whenever you see some issues with the cluster. Now API server, scheduler, control manager, kubelet, kube proxy, very, very much important. You have to retrieve the cluster logs. You have to find the root cause, like why these components are not working, why these components are not behaving properly as you are looking for it to behave, right? So these are somewhere. And if you are liking the video, like the video, guys, and comment that if you were knowing this before or not, because I am trying my best to put the efforts, even though today is Sunday around 6 a.m. in the early morning, I am recording this video, right, for you all, because I promised you all that today in the 6 p.m. this video will be released to you all. So that is why I'm making this effort. So let's move forward. Let's see, like, what are the next things that are there. Let's go into the deep way. Like, as I have told you again, the 3-rule theory app, there is a container, there is a pod, right? This is the pod, this is the container, and this is your application. Now let's imagine few of the things here, how you can get your data. Now create container config error. Now let's imagine that we have seen the pod error, we have seen the cluster error, we have seen the node error. Okay, now let's imagine the container itself is having the error. How do you go and solve these issues? Now create config container config error. This is one of the error which is coming when you are trying to create the container, right? So let's see, this error is usually the result of missing secret or config. Now create container config error. So basically, configs are nothing but whenever your application needs some additional variables, additional files, additional data. So basically in the config map, there will be some scripts which will help your pod to be up and running. And there will be some, you can consider like some variables which can help your pod to be up and running. There will be some secrets which will help your pod to up and run, right? So secret or config map, if there is an issue with the secret or config map, like the external dependency, if there is some issue, then you will see create container configuration error. Now, secrets are Kubernetes objects that are used to store the data, right? Store the secret values or more sensitive values like your Azure secrets, AWS secret manager, and all those things. Similarly, in the Kubernetes, we will have something like your secrets to be stored, right? AWS Kubernetes secrets, right? And these are the objects which store the sensitive information like database credentials, right? Config maps store the data as key value pairs and are typically used to hold configuration information. So that's what the config maps are, nothing but which are used to store your information, right? Information related to your application. Some kind of key value pairs it will have, key and value kind of pairs it will have, basically the configuration of your application. Now let's imagine that in this configuration you have errors. Now kubectl get pods is the command which you will do, and you are able to see like name, ready, what is the status of that pod, and restarts and age. You are able to see the name of the pod, whatever the container is, one container is available, one pod is available, whether it is up and running. No, it is not up and running. There means there is an issue. Under the status tab, you will check, there is like create container config error. Number of restarts, you will see 0, and age is 1 minute 23 seconds. Now, whenever you see like create container config error, your brain should be striking or tickling towards, okay, I have missed some configuration, I have missed some secret. Now what you will do, kubectl describe pod name, and you will be able to see like warning failed 34 seconds ago, error config map 3 not found. Now whenever you see this is the direct error which states that there is an issue with your configuration mapping, right? And what you have to do, very simply, you have to make sure that if the result is null, then the config map is missing, and you need to create a config map and attach it to your container. Now you see kubectl get config map. Now the config map is separate an object, as you are seeing, right? The secrets is an object, the Kubernetes config maps are object. So what is the command you will be doing? Kubectl get config map, right, and config map 3. So this is something like you will see, and if it is coming as null, then you have to create the config map and attach it to the container. So that's what you will see related to your container. Now one more error which we usually see, like image pullback or error image pull. Now you see kubectl get pods, and the status of the pod is image pullback off. Now whenever you see kubectl describe pod, there might be the issues like with your so basically image, right? This is basically with the container image. Now what are the commands that you will use, or how do you debug it? So basically you would have given the wrong image name or tag, right? Authentication issue with your container registry. Pod does not have any 𝐅𝐵𝐸 role that allows it to perform its operation. Now there are 3 things here. One, there is a wrong image name or tag. Okay, name or tag, the first point. The second point is authentication to that registry, because always a container, whenever a pod is getting created, it will try to pull the image from the registry which is available in the internet or in your local company, local area network, your local company network, it will be available. At the same time, pod does not have the 𝐅𝐵𝐸. 𝐅𝐵𝐸 is basically the role-based access control. Role-based access control is like you have mainly some kind of roles which are assigned to this particular cluster, this particular pod, where it has the access to create the containers, right? If you don't give the access to create the containers or have the access to pull the image, then obviously there is an issue. So basically this is kind of a permission issue, right? Or the image issue. So basically whenever you see image pullback error, your brain should strike for the image issue or the tag issue or the authentication issue. So these 3 are the issues which will be happening very frequently when your pod is having issues or your container is having issue. There is one more famous issue like crash loop back off. This is again kubectl get pods. You see there is a pod ready not ready state and crash loop back off. Whenever you see crash loop back, there is an issue with your resources. So basically it will be having with your CPU memory. Now there can be an issue with the volume mounting. So what is volume mounting basically is your pod, right? Suppose this is your application, right? On top of your application, this is your pod, and on top of your pod, this is your container. Now you need to understand when, sorry, I missed it. This is not the way. So this is your container, and on top of your container, there's a pod, right? Now you understand that for your container, you have created some volume mounts, right? Why volume mounts are used? Volume mounts are used to store the data, right? Why our laptop is having a hard disk to store the data. So that is why volume mounting is also important, so that you store the data. And if you see issue is the mounting a storage volume, check with the volume of the pod and ensure that it is defined correctly in the pod manifest file. So you need to open your Kubernetes manifest file and you need to check the volume and the volume claim templates. There will be 2 templates, which I have already done in the yesterday's class. If you have not seen, check the yesterday's live. Every playlist is there, free Bootcamp 6 check. We have discussed very deep concepts about your pod and your deployment sets, stateful sets, replica sets, right? Service, what are pods, everything we have discussed, and we have done the hands-on. Very good project. You should be able to see. And you see here, there is one more error, use of host port. So whenever there is an binding, if you're binding the pods to the host port, you may be able to schedule 1 pod per node. In most cases, you can avoid using the host port. Suppose sometimes what happens, the container, right? Container is again like a laptop, which will need the ports, right? And what will happen, suppose we assign this ports as the host port. Sometimes the host port will not be available, and this will be coming to the crash loop back error. So you need to make sure your ports are unique every time whenever you are spinning up the pod. So let's go see like what are the next things that are there. Kubernetes not ready state. Now Kubernetes, we have seen cluster. How do you debug node? You have seen pods, you have seen containers, you have seen. Now let's see the nodes itself are not in ready state. What you have to do. So you see kubectl get nodes. When you do, there is one node which is not in ready state, which is 1 hour ago it has run, and the version of the node is this. And you are also able to see there are some pods which are also like unknown or container creating state. Obviously the node is not ready means, you see here, if the node is not ready, the pod is also not ready. So what is that case? At that point of time, the failed node is able to recover or rebooted by the user. Sometimes what happens, you as a Kubernetes admin have to go ahead and check the failed pod, failed node, and automatically create one more node. Now Kubernetes has the very good feature where it will try to fail over the failed node, and it will create a new node automatically. And you are able to see, right? This is the, okay, I will be showing you 1 second. I'll be taking one more different color, and you are able to see, right? This was the use case 1 where your pod was not up, and Kubernetes has created one more your node 2, right? Node 2, which is having the container creating state, and it is making the pod up, right? The pod with unknown status is deleted. So basically, whenever you see what will happen, right? What will happen whenever a new node is getting created by the Kubernetes or by the human, whenever a new node is added, what will happen? The pod with the unknown status is deleted and the volumes are detached from the failed node, obviously, right? So the pod is dead. The pod is dead with the unknown status. So what will happen? Very, very much important. The pod will go dead with the unknown status. And what will happen? Immediately, the new pod will be rescheduled on the new node. Its status changes from unknown to container creating state. Unknown to container creating state. That's what you are seeing. And it is in the new node. Kubernetes uses a 5-minute timeout by default, after which the pod will run on the node. And its status changes from container creating to running. Very, very beautiful. So after the 5 minutes, journey of this pod, it will be changed, the status will be changed to the running. So these are some things which you have to keep in mind, very, very much important. So whatever we have discussed, I have made sure that you understand the important things. Now let's imagine that you have done a deployment. Okay. Now let's imagine that you have done the deployment. Okay. Now in the deployment you have done, and you have done for a version of 4.0. Now your manager is telling, or you found that in the deployment there is an issue with the pod. You want to roll back that pod. So how do you do the rollback of the pod? Is basically kubectl rollout history of the deployment name. So basically the command is kubectl rollout history deployment of the history. And what is the deployment? Suppose my nginx is my deployment. So I will be writing here nginx, and you can see here there are some versions, right? Version change cost. There is 1, 2, 3, 4 versions. And if I want to change it to the previous version, so what is the command? kubectl rollout undo deployment name to version of 3. So that's how the 4th version is reverted back to the 3rd version. Yes, you can also do from the Kubernetes dashboard. You go to the Kubernetes dashboard, you edit the Kubernetes configuration manifest file, and there in the deployment manifest file, you can change the version, right? So that's how we used to do in the Walmart also. Sometimes in the non-prod, in the production, you have to do a rollout itself from the Jenkins CI/CD pipeline. But yeah, in the non-prod, you can do all these things. Now let's go ahead, let's see what are the next steps that you are going to see. So I think that is all for you in the today's video. I hope you are liking the efforts. And yes, if you are interested in joining the Prime Batch 7.0, all the links are in the description. You can join. This is how I teach. The first 1.5 hour will be your theory, and the next 1.5 hour will be your project in the Prime Batch 7.0. You can talk with any of the students, and also you can enroll at the very least price in the market. As you all know, 4250 is very, very least in the market. You go check everywhere in the market, check with the content, check with the mentor, how the mentor has achieved, if the mentor has really achieved something or not, what is his capabilities. And yes, definitely, we are not going to do spoon feeding. We are targeting here the job ready content. So you will be getting something called job ready content itself from my teachings, right? So what are you waiting for? Check out all the links, like the video, share the channel link with your friends, and check out for all the links, like documents will be given in the Telegram group. So this is Singham signing off. Meet you in the next video. Until then, take care, stay safe. Bye. I am stopping the recording. Okay.